Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 17, Exercise A, Circles Basics, Part 1. Math Exercise 17A, Circles, Part 1. Let's understand some fundamental concepts first. In a circle, if we have a chord, AB, any chord, and from the center of the circle, if we draw a bisector, that is M is the midpoint, then that would become perpendicular to the chord. So angle OMB will be equal to angle OMA, which is 90 degrees. The converse is also true. So if I have a chord AB and from the center O, if I draw a perpendicular to the chord, then it will also bisect the chord, that is P will be the midpoint of AB. What follows is that in a circle, if there are two chords, then the bigger chord will be nearer to the center compared to the smaller chord, which will be farther away from the center of the circle. So here, if AB chord is bigger than CD chord, then OP, that is the distance from the center, perpendicular distance, will be smaller than OC. Remember, equal chords of a circle are equidistant from the circle. So if AB and CD are equal, let's say 10 centimeters and 10 centimeters, then their centers from their distance from the centers, that is OM and ON, are also equal. Remember, distance is always perpendicular, and that means that M will be the midpoint of AB and N will be the midpoint of DC. The converse is also true. So if the distances are equal, that is OM and ON are equal, then it follows that AB and CD chords will also be equal. Now we need to understand the concept of segment. This is not a line segment. These are segments of a circle. If I draw any chord, it divides the circle into two areas. The bigger area will be the major segment and the smaller area will be the minor segment. If I draw a diameter, then it will be divided into two equal halves and they will be equal segments. Now there is a theorem which says that angles in the same segment are equal, which is theorem 6, and theorem 5 says that the angle at the circumference, that is in the segment, is half of the central angle. Central angle means at the center of the circle. So angle AOB is twice angle ACB. So if angle ACB was 30 degrees, then angle AOB will be 60 degrees. This is always double of the angle at the circumference, and the angle at the circumference is always half of the angle at the center. But note that this relationship will hold true only if the points are same, point A and B. So point AOB and ACB both have the same points, end points A and B. Also, O should be the center of the circle and C should be at the circumference. If O was not the center of the circle, then we could not use this theorem. Similarly, if C is not at the circumference, it's inside or outside, we cannot use this theorem. And not only ACB, but any other angle starting from A at the circumference and ending at B. So even this angle, let's call it AEB. Even this angle will be 30 degrees. It will be half of the central angle because points A and B are the same. So there can be infinite such angles. What about this angle? It should be at B, of course. So if the end points are same, A and B, now this angle at the circumference, let's call it F, will also be half of this, so it will also be 30 degrees. That means all these angles are equal. And hence theorem 6 says that angles in the same segment are equal. Or in simple language, if there are two angles, where the vertex is on the circumference and the end points are the same, AB, so ACB and ADB, then we can say that they are equal angles. Simply we say that angles in the same segment are equal. Next, theorem 7 says that if the angle is in a semicircle, then that angle is 90 degrees, a right angle. The proofs of these theorems are not in syllabus. Next, theorem number 8. If I have a cyclic quadrilateral, that is a quadrilateral has 4 sides, and the 4 vertices are on the circumference of a circle, then the sum of the opposite angles will be 180. So they are supplementary. So this plus this is 180. Similarly, this plus this will be 180. Now we know that for any quadrilateral, any ordinary quadrilateral, the total is always 360. But for a cyclic quadrilateral, there is something special, that the opposite angles are supplementary. So this is 180 and this plus this is 180. Please understand that this is applicable only if all 4 points are on the circumference. So if you talk about quadrilateral OABC, that is not a cyclic quadrilateral because point O is not lying on the circumference. So then this property won't hold true for this quadrilateral. Although the total of all 4 angles will be 360, but the opposite angles aren't supplementary. Now there's one more theorem, exterior angle property for a quadrilateral, cyclic quadrilateral. This is the exterior angle, right? It's an extension of one of the sides. It will be equal to the remote interior opposite angle. That is, these are the interior angles. And which angle is opposite to this adjacent one? This one. So this will be equal to this. You can even solve such sum by a longer method. So when we come to such a sum, I will show you the longer one if you don't want to use this theorem then. Again, this is true only for cyclic quadrilaterals. Now there are many solved examples. The cancellations are in essay number 4, cancel the second method entirely and even the third method entirely. Question 6 is cancelled. Question 9 is entirely cancelled. Question 10 is cancelled as per the reduced syllabus. As per the reduced syllabus this year, only for this year they are cancelled. Similarly, in exercise 17A, there are many sums which are cancelled as per the reduced syllabus. Cancel question 2. Let's start with question 3. Now for each and every sum you have to draw the diagram. You can draw freehand, but draw huge diagrams and write a lot of statements. Write the reason for every statement. Presentation is very important in geometry. It may be time consuming, the sums will be long, but then you'll get full marks. 4 on 4, 5 on 5. If you want for circles, you can get a bangle, which will save your time. Any color is fine. Blue, green, like the color of the leaves, or like the misty mountains. I prefer a silver one because silver represents wisdom. But you can go for red bangles. In this sum, angle AOB is 70, so this is 70 degrees. And angle OCA we have to find. Now clearly angle OCA is same as angle BCA, will be half of angle AOB because angle at the circumference is always half the angle, the central angle. Notice that AB is the common points between the two angles. So this theorem will hold true. So this becomes 35 degrees. It's a good practice to first figure out the method using the diagram before even solving the step. You may even want to note down all the values in the diagram. And then finally you should start solving. And that is why I say that draw the diagram, a big diagram, before solving freehand, so that way you will be able to write the values as well, because these diagrams in the textbook are quite small. So as the sums become more complicated ahead, It'll become too messy to write in such a small circle. So draw it. Angle OAC is the next question, this one. Well, triangle OCA is actually an isosceles triangle because OC and OA are radii of the same circle. And you know what happens if it's an isosceles triangle? The base angles, that is angle C and angle A out here, will be equal. So even this becomes 35. When I say angle C and angle A, I used single letters to denote the angles because I had mentioned in triangle OCA. So if you're mentioning the name of the triangle in the beginning, then you can address the names of the angles with a single letter, angle O, angle C, angle A. Otherwise, it becomes necessary to use a 3-letter naming for angles, that is angle AOC, angle OCA and angle CAO, to avoid confusion. Because if I say angle A, it could even mean angle OAB, even that is angle A. So in the sums, usually you should use 3-letter naming for all angles. Only if you are talking about a particular triangle do you have the freedom of using single letters. Now the steps. These are the steps. Next, let's study 5.1. So here I have to find angle A. If only I could know the entire angle B, then I could have used angle sum property. But I don't have entire angle B. I'll have to use some other method here. What is given is that dB is a diameter. See, it is passing through the center O. I'm not assuming that, but it's given in the question. So that will prove useful. Let me just mark this as 90 degrees. That is angle DAB. Don't just call it angle A, call it DAB is 90 degrees. Reason? It's an angle on a semicircle. That is why. That's useful because out of that, the smaller angle CAB is given as 70. So this even smaller angle DAC will be how much now? 90 minus 70, that's 20. So let me write 20 out here. Okay. Now what? Well, if you look at triangle DAB, angle A is entirely 90, angle B is 35. So I can find angle D by angle sum property. So 90 plus 35, 180 minus that. I'm getting this as 55. Angle sum property in triangle DAB. And angle ACB is also equal to angle ADB because they are in the same segment. Notice how AB is common for both the angles ADB, ACB. They are cutting the same arc. ADB is cutting arc AB and ACB is also cutting arc AB. So they have to be equal. You know why? Because they will have the same central angle. That's why they are equal. That's the theorem. With a lot of practice, you will be able to visualize this. You have to visualize which angle is equal to which one. So that means A is also 55. Can you think of any alternative method to get this answer? In geometry, there are so many alternative methods, and you should always try to think on your own for alternative methods because it deepens your understanding of geometry. What I can see is if this is 20 DAC, then even DBC will be 20. You know, they are cutting the same arc DC. They are in the same segment. So if DBC is 20, then this becomes entirely 55. And now in triangle CAB, I can use angle sum property because I know an angle A 70 and angle B entirely is 55. So angle A will also be 55 by angle sum property. So that was another method. So there could be many methods and all are correct as long as your steps are right. And how to write the steps is the most challenging part. Solving it in the diagram is only half the battle won. But what matters in exam, what you write on paper. You may get the right answer 55, but what about the steps? What about the reasons? The reasons should be mentioned, so be very careful about it. Now let's do 5.3. Since you know all the theorems, I suggest before every sum you pause, you read the question, look at the diagram and just solve it with a pencil the way I am doing. That won't take much time because I'm not asking you to write the steps. Steps you can copy from my book picks, but here just try to work it out and try to see if you're getting the right answer. Then you will enjoy this chapter and you will realize that actually it is a very easy chapter now that the proofs are not there as per the reduced syllabus. And especially part 1 where we are doing only till sum to 32, they're all very easy sums and small sums. So tell me, how will you find angle C? Guess. Ready for the reveal? Okay, if this is 50, central angle will be double of that, 100. And this is an isosceles triangle, radii. So let's call it C, then this is also C. So C plus 100 is 180, so C is 40 degrees. So that was such a small sum, but not quite. Writing makes it longer, especially all the steps and the headings, all the reasons. You should write, you can add 2-3 more steps to make it simpler. You can first prove it to be isosceles triangle, then move on to the angle sum property. Cancel the 6th sum and let's do the 8th sum. Here, 2 angles are given, 140 and 150. First angle ACB. How will you find it? Think about it. Pause and think. Do you think that this and this will be supplementary? That's wrong because it's not a cyclic quadrilateral. O is not on the circumference of the circle. Nope, that won't work. What else? How do I find this angle? Well, we know that every angle is half the central angle. And for angle ACB, which is on the circumference, the central angle will be this one. That is reflex angle AOB. Reflex angle AOB. See, angle AOB is 140. But the remainder of the angle is also called angle AOB. It's called a reflex angle. Reflex angle is always greater than 180 degrees. And you know, this is 360 degrees. Because they are angles around the point. So if this is 140, then the reflex angle AOB will be how much? 220 degrees. Now, if that is the central angle, then angle ACB will be half of that. Understand that angle AOB 140 cannot be the central angle for angle ACB. The central angle and the circumference angle never face each other. Look at this one. Here, angle ACB and angle AOB are not facing each other. Similarly, here also, this angle has a central angle called reflex angle AOB. So this will be half of 220, which comes up to 110 degrees. If you want a longer method, then do a construction. Just join this. Now if this is 140, then half of that is 70, so this becomes 70 degrees. Now this angle plus this angle are supplementary because now I have created a cyclic quadrilateral, so 70 plus this is 180, so this will become 110. So that's a longer method. That is fine. You can use that as well. Next, angle OBC. That is this angle. Now how do I find this one? Well, in this quadrilateral, I got 3 angles already, 50, 140, 110. And I know the sum of all angles is 360 degrees. So obviously this will be 360 minus the sum of this, which comes out to be 60 degrees. Next, angle OAB. For that, I'll have to draw a line here, straight line. Like this. OAB. Nope, it won't be half of 50. Don't assume anything. Well, let's use isosceles triangle property in triangle OAB. OA is equal to OB, radii of the same circle. That means this is equal to x and x. X plus 140 is 180, angle sum property. And hence, this will be 20 degrees each. So this is 20 and this is also 20. Finally, angle ABC they want. Angle ABC. Well, we know total angle OBC, we found out it was 60 degrees. Out of that, this is 620 degrees. So this will be subtraction 40 degrees. Now here are the steps, right? Exactly the way I have. This is angles around a point, 360 degrees totally. Not a single statement should be missed. Next, we move on to the 10th sum. Here again, some values are given and some values are to be found. First, angle BDC, this one. How do I find this one? Angle BDC. They have given the total angle D as 77. If only I can find this one, ADB, then I can subtract it to get BDC. But how do I find ADB? Using triangle ADB, angle sum property. In triangle ADB, angle A and B values are given, so you can find angle D value, that is ADB value, which comes up to 47 degrees. So if this is 47, then subtract it from 77. How much is this now? 30. Next, Roman number 2, angle BCD, this one. Don't assume that they are radii or anything. There is no diameter or center of circle mentioned. Although ABCD is a cyclic quadrilateral, so that means angle A and C are supplementary, total 180. So if this is 75, how much will this be? 105. Good job. Now the only thing left is angle BCA. Oh, you have to draw a line here. Okay, so now tell me, how will you find angle BCA? Won't angle BCA be equal to some angle? Come on, can you visualize it? Angle BCA is equal to one angle at the circumference which also has endpoints B and A. Well, it is angle BDA. BCA is equal to BDA. Reason, angles in the same segment, and BDA we have already found out. It was 47, I think. Yes, it was 47. So even this is 47 BCA. So these are the statements. 47 degrees, angles in the same segment, or in simple English, cutting the same arc BA. But don't write that. 12th sum. Now again, two values are given and they want angle DAB and ABD. Let me just mark it, this angle, and ABD is this entire angle. Well, both of them belong to triangle ABD. So if only I could find the angle ADB, then I can simply say 180 minus that is this plus this, angle sum property. But how do I get angle ABD now? Has to be a way. Well, won't angle ADB be same as ACB? Angles in the same segment. See, ACB, ADB, both ending with AB, and both of them have C and D vertex points at the circumference. So yeah. So now my target is to find angle C out here. How do I find that? For that, let me use triangle ACB angle sum property, because in triangle ACB, I know angle A 75. I know angle B is 50. Was it for the whole angle or the? No, only for the smaller angle. CBA 50. So angle sum property, I'm getting the answer as 55 degrees. So if this is 55, then this is 55. If this is 55, then this angle plus this angle will be 180 minus 55, which comes out to be 125 degrees. Here are the steps. Try to write the steps on your own. After I explain the sum using the diagram, you should be able to write the steps on your own. But then do check your steps to see if you've written it with such detail as I have, with all the reasons which I have, because only then you'll get full marks. If you've been doing shortcut in your lower standards, well, now the time is to shed off that habit. Now the 14th sum. Here, this is 110 and I have to find the value of x. Okay. Anything given like parallel? Nope, nothing. I know that angle CDB will be half of angle COB. Do you agree that COB is actually the central angle for CDB? Notice how both of them end with CB. Both of them are cutting the same arc CB. So yes, indeed, if I can find this angle, I can find x, because x will be half of this angle. So now the question is how to find this angle. Think. Linear pair. This is a straight line. Straight line means totally 180. If this is 110, this will be 70. If this is 70, this is 35. Done. Such an easy sum. These are the steps. Next, the 16th question. Here, these three angles are given. We have to find DBC, this one. Oh, that's easy. It is equal to some angle. Which angle? Say it. DBC is equal to DAC. DAC and DBC are cutting same arc DC. Angles in the same segment. So if this is 27, this is 27. Let me write it. 27. Now DCB, this one, whole thing. How do I find that? It's a cyclic quadrilateral, I know, but I don't know this entire angle. Then let's find the entire angle in triangle ADB. If this is 33 and this is 50, angle sum property, I can find entire angle A, which comes out to be 97 degrees. If this is 97, then angle A and angle C are supplementary. It's a cyclic quadrilateral, so this will be 180 minus 97. That's 83, so I'm getting this as 83. Great. Now find angle CAB. CAB is nothing but DAB minus DAC. Totally this was 97, out of which this small is 27. So how much is left here? 70. So these are the steps. Next, let's go for 19th sum. Cancel the 18th one. 19th one. This is 96. So first of all, find BCD. That's simple. It's a cyclic quadrilateral. A, B, C, D. Please go clockwise or anti-clockwise while naming. Don't do A, B, D, C, zigzag naming. Not allowed. In a cyclic quadrilateral, the opposite angles are supplementary. So if this is 96, this will be 180 minus 96, which comes out to be 84. Next question. Find BFE. Well, the shorter method is, even this is a cyclic quadrilateral and this is an exterior angle for that. An exterior angle is always equal to the interior opposite angle. So this will again be 84. If you don't remember this theorem, then a longer method would be, if this is 84 linear pair, this will be 96 linear pair. So 96 totally should be 180, right? And if this is 96, opposite to that should be supplementary, because in a cyclic quadrilateral opposite angles are supplementary. So 180 minus 96 is 84. So even that method is fine. Now we have to prove AD is parallel to FE. Now I see that this is 96 and this is 84, and these angles are forming a C shape. Now whenever you have two lines and you have a transversal and the allied angles, that is the co-interior angles, are supplementary 180 degrees, we can say that the two lines are parallel. So AD is parallel to EF by co-interior angles test or allied angles test. There are many tests like corresponding angles tests, alternate angles tests, but here the allied angles test proved useful. The B part is cancelled. So now the 19 sum steps. These are the 19th sum steps. Cancel the 20th one, 21st, 22nd, 24th. Let's do the 25th sum. This is 29 degrees and they have said this is parallel to this. So immediately I know that this is 29. I don't know if it's useful or not, but let me just write it down. 29, 29, alternate angles, right? It's forming a Z. What else? They have mentioned RS is a diameter. Definitely there's a purpose behind it. Otherwise, why would they mention it's a diameter? So if I could join MS, I know that this is 90 degrees. Angles in a semicircle might be useful in this sum. Now let's read the question. R and M. Okay, let me join this as well. Is it a cyclic quadrilateral? Yes, it is. It is a cyclic quadrilateral. All four vertices are on the circle. Interesting. RNM. How do I find this one? I don't even have any central angle. No, it won't be 90 degrees. RM is not a diameter. What can I do? Well, in triangle RMS, I know 29, I know 90. So by angle sum property, I can find angle S, which is 61. And then in cyclic quadrilateral, opposite angles are supplementary. So if this is 60, this will be 180 minus 61, which comes out to be 119. Got it. Now, second one, Roman number 2, NRM, this one. How to find this one? Nope, it's not isosceles. So, okay, again in this triangle, angle sum property, this is 119, this is 29. So this will be 180 minus that, which comes out to be 32 degrees. And that's why writing the values with pencil in the diagram is useful, because you're able to visualize and think about which theorem to use. Isosceles, angle sum property, exterior angle property, cyclic quadrilateral property. You have so many cards up your sleeve. 27th one cancelled. Let's go for the 29th one. Cancel 28th and 30th as well. In the 29th sum, this one is 35 and this one is 25. First of all, they want PRB. This one. Oh, that's easy. This is 35. This is also 35. Angles cutting the same arc in the same segment. PB is common. 35. Let me write it. Also, they mentioned diameter. AB is diameter. You know what it means? This is 90. This is also 90. Yeah, linear pair. What do they want? PBR. PBR. This whole thing they want. How do I get that now? PBR. Well, in triangle PBQ, angle PBR is an exterior angle. And in a triangle, exterior angle is always equal to the sum of the interior angles. That means angle PBR is equal to angle BPQ 90 plus PQB 25. So that turns out to be 115 degrees. So 115. A longer method is angle sum property, find the value of B, 90 and 25. So this is how much now? 65. And if this is 65 linear pair, this is 180 minus 65, 115. Same answer, but longer method. Finally, BPR. BPR, the small angle out here. How do you find the small angle out here? BPR. Well, again, in triangle BPR, you have 35, you have 115, angle sum property. You can find this angle. Now, the 31st sum. First of all, this is 150. That means this will be half of 150. This is the central angle for this circumference angle. And circumference angle is always half of central angle. So if this is 150, this will be 75. And if this is 75, linear pair, this will be 180 minus 75, which is 105. And if this is 105, then its central angle will be double of that. So that will be 210. Central angle's name is reflex angle BCD. But before that, 29 sum steps are here. I hope you solved the previous sum also. The steps are here. 25th sum steps. Let me show you all the sums from the beginning. So you can pause and check all the steps. And now the 29 sum steps. It comes out to be 30 degrees. And then 32nd sum steps. Final answer is 150. Because if this is 210 and angles around a point have to be 360, so this will be, x will be 360 minus 210, which is 150. Another method could be that, no, that will be too long. No, x and 105 are not supplementary. It's not a cyclic quadrilateral. The other method I was trying to say is that you could draw a cyclic quadrilateral 105. So this will be supplementary, that will be 75, and then x will be double of 75 because it's a central angle of that, and that will be 150. So if you want to do it like that, you can. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.